So for today's project, I'd like to make an indexing tool. Now I'll explain what an indexing tool is a little bit later. But what I'd like to do is I've seen these somewheres, and for the life of me I can't find it. I can't even get a name on exactly what it is, but it's a tool that will be used, and it will have four sides that are perfectly square in relation to each other. And then I'd like to have 6 sides in one location that are, again, precise angles from one another, and also 8 sides. And my plan is to combine all 3 of these together into one tool. And like I say, there is such a tool that exists. For the life of me, I don't know exactly what it's called. But my plan is to combine these on top of each other so that they're stacked and all together in one tool. So let's get started, and we'll see how it turns out. So here's the raw material. It's 1x4 aluminum flat bar. And I think what I'm going to do first is square up the 2 sides, make sure same dimensions this way, even though that's not overly critical. I guess the critical thing is that it's perfectly square, or as close as we can get it. And then I got to get a pretty good size hole down the center. I'm probably going to put a 2 1/4 inch hole so that I can use this device on 2-inch shaft as the largest, and anything from there on down. So we'll get started with that. So I've got the sides squared up. So now the next step is going to be putting a big hole in the center of it, about a 2 1/4 inch hole. Now there's probably lots of ways to do this. I'm not a machinist, and I have somewhat primitive tools, so don't laugh when you see this, but the way I'm going to do it is with a hole saw. So here we are. I've got the block all marked out, and I've actually drilled a hole here. And as you can see, the reason I'm making my own, I kind of want to change the design a little bit, so this will work in smaller shafts as well. And that hole is actually going to be a very important piece in drilling through this with a hole saw. And I'll explain that more in a minute, but what I think I'm going to do, I was going to maybe do this in the drill press, but I think rather than do that, I'm going to stick it in the lathe. It's just more controlled, I feel, and I'll drill the hole through the center in the lathe. Now I've got it set up in the lathe, and yes, I realize there are better ways to do this, more accurate ways, yada yada yada, but anyways, I've chosen to do it this way. And it's to demonstrate, I guess, kind of another little tip, we'll say. I'm sure once I mentioned that we're going to use a hole saw to drill through 1-inch thick aluminum. Anybody that's used a hole saw probably was having nightmares as soon as I said that. It becomes quite difficult when you get into your thicker materials, and they're very easy to burn them up, gum up the teeth on the hole saw. So I've learned a trick over the years, and what that trick is, it works out great for this project because it's going to actually be incorporated anyway. But if you drill a hole around the area that's basically right where your teeth are going to lie, it gives a place for your chips to go as you're drilling, and it makes it 100 times easier. Much more efficient. You don't have to keep taking the hole saw out and cleaning the teeth out and recutting. This way it has a spot for your chips to go, and it will make your life much easier. Now it works out great for this project because part of my design, I had a hole right here anyway, so let's give her a shot and see how it goes. Now that I've got the hole started, this will kind of illustrate it better. The cut path is right on the edge of the hole. The chips can fall out through the hole, and you can keep on cutting. It doesn't clog the teeth up. It'll save a pile of time, aggravation, and it'll actually save the teeth on your hole saw. This works great for wood, steel, aluminum, anything. Highly recommend doing that. And because of this design, what I'm doing here, the hole's on the outside. Normally you would put the hole on the inside, the piece that's going to be wasted anyway, just along the edge, just enough to catch the teeth, or the path of the teeth, so that your chips can go through the hole. And probably a bigger hole, the bigger the hole the better, easier to get the chips out through. Now I'm over halfway through. I haven't been a minute. Look closely and you'll see the chips coming out through the hole like I was talking about. So as you can see, we're here in the mill. I've got my hole, and I've actually made my first pass. This is going to be on the six-sided part of this indexing tool. So I've made one pass. Now I'm actually going to take the block out and cut the opposite over here, and then I will rotate my table and take one across here and here to come up with my six-sided indexing part of this tool, and then I will step down, take another cut the same depth, and do the same but make it eight-sided. So that way when you're milling your round stock, you can more precisely index it, divide it up 3 ways, 6 ways, 4 ways, 8 ways, whatever you need to do. So I'm going to proceed on and cut the other side. So here we are. I know I've skipped a lot of footage here, but it's just machining. But I've got the 6 sides done on this part of it. So now what I'm going to do is set down another third of this 1-inch block and cut it on a different angle to make eight-sided, or to make an eight-sided index. So here we are, I got the first cut on the eight-sided index done, or I'm going to call it the eight-sided part of this index. I'll explain how this whole thing works after I get it machined, but anyways, I'm not going to waste too much time. I work at this a little bit one day, it might be a day or two before I can get back at it. Just something I'm kind of doing in a little bit of free time I have. So I've got a little bit of free time here right now, so I'm going to try and machine as much of this as possible. So now I've got all the machining around the perimeter complete. Turned out real decent, really. I can't complain with that. I don't know if you'll remember, but I did have a line kind of scribed across here. That'll be the only machining left. I have to remove some material on the inside diameter of this to kind of make this shape like a V. And then I have to drill and tap a hole down through here. So here it is. We're getting a lot closer. I've got this machined out now. Everything's deburred. Nice finish. Now all that's left is to drill and tap a hole down through the top here for a set screw. So here it is. The project is complete. Made my set screw, which is a bit long, so I'll probably cut that down. And now I can kind of demonstrate the purpose of this thing. So what it is suppose I had this shaft in the mill here and I wanted to cut a keyway in it. Or perhaps I had to cut 2 keyways that had to be perpendicular or 90 degrees from each other. Before, I had a very hard time to figure out 90 degrees. Well, now what I can do is I can use this in a square, and probably should have a better square than this, but I'm able to use the block on this shaft. Sorry, I'm doing this one-handed here. I'll rotate it, and then for my next keyway, turn it shaft and all in the vise. Use your square on the table, to get it square, and clamp it. And like I say, the reason for the 6 and the 8, suppose you wanted to make a nut, something like so. As you can see how I did it before, not very good. Well, now I can use this and square off these edges, and 6-sided, 8-sided, 3-sided, whichever you need to do. 45 degrees, 60 degrees, it'll all work out. Right now I've got a 2-inch shaft in it. It should work down to 1/2 inch, which hopefully you'd never be really doing too much with a 1/2 inch shaft, but anyways, it's adjustable just in case. Well, that concludes my little index project. Now, I realize you can buy something like this, and it's exactly where I got the idea. I kind of get a little bit of enjoyment out of making my own tools, and kind of get that satisfaction, and then using them, putting them to work. Good practice, I guess. But anyway, tune in next time and we'll see what we got on the go then.